Good afternoon, everybody. Am I all right? So it may take me a moment because there's a couple of different mics I'm supposed to use, and we're going to be switching mics, but I think it'll be fine, just as long as y'all can hear. If you can't hear, please go ahead and stand up and wave us down, because we want to make sure that you get all of this good info here. All right. Since I'm already talking, I might as well keep going. Welcome everybody to the workshop for preparing for the National Spatial Reference System Modernization. My name is Galen Scott. I am the NGS Constituent Manager. Been around for about a little over 20 years now, and I meet people, connect people, and talk about this stuff. So if you need to know anybody specific in NGS, let me know. I can point you to the right person. We have a couple of other speakers here today. We have Dr. Dan Roman, who is our Senior Advisor for Geodesy for NOAA. And we have Charlie Gohagen, who is our NGS Mid-Atlantic Regional Geodetic Advisor, one of 14 advisors around the country to support geodetic needs. We also happen to have our acting director for National Geodetic Survey here today, Brad Kearse, up here in the front. So this is all about engagement and talking to you, making sure that you get the basics about what we're doing with modernization, and introduce us so that you can ask questions as you need to over the next couple of years. So I'm going to give it to Dan here for a moment to give us a quick overview, and then back to me.
The bottom line is, those of you that are here today, I do appreciate it, because you understand it, you get it. The concern is everybody that's not here, and we need you to try and reach out and really start to push this forward with some of your colleagues to make sure they understand that this is coming, and you'll start to see some of the impacts as we get into this a little bit more. A lot of it's programmatic, what we're going to do, the software, the plans for how we're going to do it, and some examples of the tools. But in practicality, you're the ones that are going to have to do this. We help you position your sensors. It is you that does the sensing and it makes your observations, and you have all the data. So it is a consequence for you that you need to understand how to do this, because you're the ones who are going to have to migrate your data. And for those that are here, that's great, but I'm more worried about the other 400 or so agencies that are not here that also have geospatial data that will have to migrate as well. So this is part of a beginning of our outreach efforts. I mean, we've been doing it for a while, as Galen's noted, but we will also be continuing this over the next few years to really try and get people moving forward on this. So again, I thank you for being here and for taking an early interest in it, but we're going to be continuing to press forward, and we're going to try and engage as many people as possible. And you'll see in here there are opportunities where various agencies can participate in and gain other ways of supporting these activities. So I'll turn it over to Galen for some introductions, and then we'll get into it.
All right, folks. So we want this to be interactive to some extent. There's plenty of time for questions and answers, and we do hope that you've been thinking a little bit about the data for your agency and what questions you have about moving to the new system. Without further ado, let's roll. All right. So we're going to give you an overview of modernization today. There's so much going on that it's really hard to talk about everything. I can't go down multiple rabbit holes because there's lots of different technical understanding, different pieces of this, but this conversation assumes that you have some general understanding of what's happening. But if you want to dig in a little deeper, we've got lots of resources out there. We have a presentation library where our presentations get posted. We have our new datums page, which we are in the process of updating again. And we have a whole series of blueprint documents that kind of lay out the technical background of what we're doing. So don't expect to know everything about modernization, but hopefully an introduction to enable you to ask more questions. There we go. All right. So just a brief history. So NGS is part of our nation's oldest science agency. We were founded in 1807 when Lewis and Clark came back, and Thomas Jefferson said we need to make maps of the coasts to basically help improve commerce and safety of navigation, because we were losing a lot of ships. In 1811, Ferdinand Hassler became the first superintendent of the Coast and Geodetic Survey. He was also the first superintendent of NIST, so nice cross-pollination back then. Over the years, we've moved a couple, through the history, but basically we are now in Department of Commerce, within NOAA, the Oceanic and Atmospheric Administration, within the National Ocean Service. And the three different parts of what used to be U.S. Coast and Geodetic Survey are us, National Geodetic Survey, Colleen's group, COOPS, or the Center for Operational Oceanographic Products and Services. Those are the folks that do tides and currents. And then we also have the Office of Coast Survey that makes the nautical charts. We all work together in different ways, as Colleen mentioned, COOPS is updating the National Tidal Datum Epic, and we are updating the geodetic datums in reference frames. Geodetic control, the foundation for all maps, right? Geodetic control is the foundational layer for geospatial products. With geospatial control, you can get all of your different data layers to line up appropriately so that you can use them together and better turn data into information. You can think of geodetic control as points with coordinates. Now, as we're moving forward, you can think of them as points with coordinates as a function of time, right? That's a big thing that we're dealing with now, is making this a dynamic reference frame to better understand the dynamic Earth. Right? So without this geodetic control layer, all those different data layers that all of these different federal agencies and state agencies are producing wouldn't necessarily line up as well as they need to be able to work well together. And the idea here is that your geodetic control is more accurate than all of your other data so that it can all be referenced to each other. Charlie. This is critical for many, many different applications, right? From aviation to precision agriculture, oil exploration, everything that is geospatial. Any data that has a geospatial, a place component needs to have this reference system so that you can work these things together. I really like to think of infrastructure that goes over the horizon, right? When you need to think about the Earth as a round object or not flat, you need that geodesy. You need to be able to use that math for a curved surface. And that, for highways and railways and pipelines and all of that stuff needs to be able to be referenced to a system that can account for that curvature. So it all works better together. So this is foundational to everything that we do. All right, today, right now, the National Spatial Reference System is latitude, longitude, elevation, gravity, shoreline position, a couple other things, and outside the box changes over time, because we haven't really been able to do that well with the current system. Current system is NAD83 and NAVD88. Actually, put this down for a second. Anybody heard the joke of the one-armed fisherman? No? Caught a fish this big? Right? You need that left hand. That left hand is the datum, right? That left hand, when my daughter was born, she was this big, right? It's that left hand that you need for measuring heights and depths and distances, right? That's what we're talking about. That reference frame for all spatial data is that left hand. Today's current left hands for the horizontal and vertical are NAD83 and NAVD88. And as you can tell, those are from last century, right? The other thing to point out here is that historically we have referenced these spatial reference systems to survey control, vertical or survey marks in the ground, brass discs in the ground, other permanently placed survey marks that were the access points to, or still are, the access points to the National Spatial Reference System. Charlie, and you can click right through this, Charlie. The current extent of the current NSRS covers all of the different U.S. and our territories around the world, but they are separate, disjunct. They are, keep clicking there. All right. So for each of these places, we have a different reference frame, right? We have different vertical datums for different places. And that's just because of the way historically they were created. Go ahead. Problem is that the current system, one of the problems is that the current system, NAD83, is offset from the center mass of the Earth, okay? Back in the day when we made NAD 83, we had our best estimate of the center mass of the Earth that we could produce at the time with the best science at the time, and that was the origin point for NAD 83, right? Over time, as a scientific community, that we've better understood the center mass of the Earth and where that is, and we now understand it to be about 2.2 meters away from the point that we used for the origin of NAD 83. Now, other frames, like the International Terrestrial Reference Frame, ITRF, that's the global reference frame that everybody around the world agrees to use for global applications. We then take that international frame and warp it and change it to fit our national needs, which is one of the things that we'll talk about here in a minute. But there's that difference between NAD 83 and the current ITRF system, where the geocenter, the origin point for the whole system, is 2.2 meters off. So that percolates into a whole bunch of other issues, right? Go ahead. So the horizontal difference can be up to 4 meters, right? Particularly out in the Pacific. We're talking significant shifts here. So just changing that, there's two things going on. We're changing the origin point. We're also changing the datums themselves and fixing some of the errors and biases and tilts that were in the original systems or the current systems. So you're gonna see a significant shift in different places around the world, right? In different places. Next one. All right. The vertical is really is critical because, as Brad mentioned, it's about where water flows, right? Understanding where water goes is really important to this. Understanding NAVD-88, the North American Vertical Datum of 1988, is comprised of basically 80 to 100 years of geodetic leveling. These geodetic leveling crews literally walking across the country, east to west, north to south, over decade after decade, connecting very, very precisely over 800,000 benchmarks with 2.2 million kilometers of leveling, and all of that getting adjusted together back around 1991 to create that NAVD-88 surface with the 0 point up at Father Point Rimouski in Canada, right? So you can say that's a 0 point, we know height differences all the way across the country, and we can compute the heights on all of those marks based on that 0 point that we picked. Now the problem is as we know, the Earth's a dynamic place. And so over those decades and decades, things moved. But when we created NAVD-88, the only information we have was the last time it was leveled. So the last time it was leveled, that information came and was used, and it was not necessarily representative of where the ground was, where those marks were then or now, right? So NAVD-88, take all this data, mash it together, and give us this new vertical system that was released in 1991. And then GPS came along, right? Fundamentally changed the way that we do surveying. Provide access to, instead of those marks, what we like to call the geodetic firmament in the sky, right? We can now access coordinates, we can now access positioning information from these satellites, and not necessarily need to do that from the marks in the ground. But over the past 25 years or plus, we have created a system where you can get GPS, take GPS data, apply a model of gravity called the geoid model, and get NAVD-88 heights from GPS, right? Actually, it was our scientists that figured out, at NGS, that figured out how to get around the selective availability that was reducing the accuracy precision of GPS back in the day, and brought GPS to the civilian surveying community. So, next one. And I'll talk about the geoid models in a second here. But so the issues with NAVD-88, just to visualize this, right? You have a level line that goes through an area in 1954. It's the last information that we had in 1991 about those marks, right? So in 1954, we collect that leveling data. In 1991, we processed it and we adjusted it all together. But in the intervening decades, that whole area sunk, right? Click again and again, you've got our published NAVD-88 height is back up where it was in 1954, but the actual height is lower. Unless we really understand how things were changing in that particular area, we don't know how much lower. You have to resurvey it, right? And so that's one of the issues with NAVD88 is unless it was resurveyed and unless that data was given to NGS to update NAVD88 in areas of motion, there was error in it, right? There is error in it. But again, this was the best technology at the time, and now we have better technology. So that's a major reason why we're moving. Go ahead, next one. So, and just an example, there's a lot of vertical motion, and in some places it's really extreme. There's more up-to-date photos than that USGS one on the far right there. Things can move fast, right? Particularly when you're pumping out subsurface fluid, whether it's water or oil and gas or whatever it is, things can move fast. So being able to understand and measure relatively easily how things are changing is one of the big reasons why we are making this change. Go ahead. So starting in the late 1990s, I told you after we finished NAVD88 and GPS came out, we figured out that if you go out there, collect GPS data on those NAVD88 marks, and basically create a model of gravity called the geoid model, and then warp that model to that GPS data on those NAVD88 marks, we could create a model that could give you NAVD88 heights from GPS. And that's what we've been doing for the last 20 plus years. Those are called hybrid geoid models, and we've had a whole series of them over the past bunch of years. Now, we kept getting better and better at it, right? Because we would get more data and we would do the modeling better and such. But one of the issues with that is that you've got folks like USGS with their stream gauge network that are tying into NAVD88 with GPS, over the past 20 years, but using different geoid models as they came out, right? Which, you're using the best data at the time, the best model at the time, but that introduced an inconsistency. We could have one river stretch where you have different stream gauges that are referenced to NAVD88 using different hybrid geoid models. That creates a step function, and that is essentially the difference between those geoid models in those areas. So that's one of the reasons. That introduced an inconsistency in NAVD88, and another reason why we're moving to this newer system. One of the other things that we did recently was collect a big crowdsourced data collection campaign to collect GPS data on those NAVD88 marks. First, it was to create the last hybrid geoid model, which is currently Geoid 18. That's the current hybrid geoid model to give you NAVD88 heights. We continued that we got 7,000 new data points for Geoid 18, which was great. Really improved the local accuracy of it. We then continued that project over the last several years to collect that data to use in the new transformation tool to transform between NAVD88 and NAPGD 2022, which I'll talk about in a second. So that GPS data on those NAVD88 marks is really that bridge between the current system and the future system. Good. All right, so why are we doing this? Lots of different benefits, right? One, as I said before, to correct that difference in the geocenter, right? Because it was defined before GPS. Oh, the other important thing about that, the geocenter, the center mass of the Earth, that's what the satellites are orbiting around. That's why it's important, right? Historically, as I said, we rely on access to the reference frames through physical survey marks in the ground. Now we can do it through GPS. Pretty much anywhere you need to get GPS, you can get a new coordinate there. Today's technology is much better, and everybody has spatial technology that is getting better than the frames themselves. Another reason we need to move and improve the frames, because the use of geospatial data is democratized, right? Everybody can do it with their cell phone. Now we need to make sure that the whole system underlying it can support the accuracy needs of today's applications. This improves accuracy, alignment, access really anywhere, but there's also billions of dollars in benefits. A lot of that's from improved floodplain mapping and increased understanding of geohazards and such. We have a socioeconomic benefit study that talks about that, gives more details. But there's a lot of benefit to moving to this new system because of the increased accuracy and such, and early adopters will derive more benefits, right? So there's an incentive there to move to the new system sooner than later because you start deriving those benefits earlier. And then also, it will allow this better integration of data, whether it's from NOAA, from other federal agencies, state agencies, just better alignment of all of this geospatial data so that we can better turn that data into information. Good. All right, so the new system still is latitude, longitude, elevation, shoreline position, and we have a better way of incorporating those changes over time. We're gonna have, and the whole, instead of passive marks in the ground, those brass discs, everything is based on GPS, and specifically continuous GPS, part of our CORS network, our continuously operating reference station network, which I'll talk about momentarily. From NAD83, we're going to 4 tectonic plate-based reference frames. That's going to be, and those are for the 4 tectonic plates that the US and territories, North America, Pacific, Caribbean, and Marianas. So NatRef, CatRef, MatRef, and PatRef. And I'll show that a little bit more in a minute. We're also going to have a new geopotential datum, fancy word for our new vertical datum, to replace NAVD88, and that's going to be NAPGD, North American Pacific Geopotential Datum 2022. So that's, in a nutshell, the new system. Go ahead. So we're getting rid of NAD83, we're going to NatRef, PatRef, MatRef, and CatRef. We're getting rid of hybrid geoids, and we're going to a fully gravimetric geoid model. We're not going to warp it to those NAVD88 marks anymore. We're going to let the gravity speak. That's going to be geoid 18. We're getting rid of all of those island-based vertical datums, right? So all of those different island territories had their own vertical datums based on tide gauges. That's all going to be replaced by NAPGD. And instead of all of our old tools that were built separately for different things, mostly in Fortran, we're going to be using modern code, modern tools. Go ahead. Am I getting, all right. Next one, Sarah. All right, so as I said, these are the tectonic plate-based reference frames. One thing to note is that NAD83 actually modeled both the North American plate and the Caribbean plate together. Now we know, we have more information about how those plates move, and so we know that they move differently. So we're now have a CatRef frame that is on the Caribbean plate and a NatRef frame that's on the North American plate. And you can see where the other plates are. Next one. The new geopotential datum. So one of the limitations of NAVD88 was that it stops at the water's edge, right? Because as one of our old colleagues used to say, unless the Lord Almighty is your party chief, you're not leveling over water, right? That created a limitation where NAVD88 stopped at the shoreline. Now we're gonna have a gravimetric-based geoid model that covers the entire northwestern hemisphere of the planet, okay? So it cuts across that land-water interface, which allows integration of data at the shorelines and on rivers, inland river systems and things that is continuous. That doesn't stop at the shoreline. We have one reference frame that can cover that whole area. So things are much more consistent and accurate across the whole area. There's a whole series of other models that are included in this, and we won't go down the rabbit hole with those. But there's three grids. The main grid for Geoid 2022, as I said, the whole northwestern hemisphere, but because American Samoa and Guam and the Commonwealth of Northern Marianas are so far away, we decided to make separate grids for those rather than extend the big grid, because that would have been too much. So several different pieces of NAPGD, and we can answer questions about that later. Go ahead. So what are we doing? Just in general, kind of summarize this up. We're defining new terrestrial reference frame parameters, specifically working for NatRef, working with the Canadians and the folks in Mexico to create the NatRef coordinates system. GravD is one of my favorite acronyms, GRAVITY, for the redefinition of the American vertical datum. It's been going on for 16 years now, collecting airborne gravity. I'll talk about that. That was the big pole in the tent for creating the new datum, the new geopotential datum. The terrestrial reference frame's GravD for the new geoid model. There's a new state plane coordinate system, right? Because a lot of surveyors, especially if you're only working in a local area, don't really care necessarily about that curvature of the Earth. We're creating a whole new, and it's out there now with the new zone definitions, making the Earth flat again, one zone at a time with the state plane coordinate system. We are continuing to accept GPS data. While on those NAVD88 marks and any other marks, you can collect that data and submit it to us. Now that data will be used to compute new coordinates in the new frames. So if you've got survey control networks that you want to move to the new frames, you can survey them now, submit that data to us, and we'll compute those new coordinates in the new frames when they get released. And then we're going to have a whole series of new geospatial data tools that are more integrated and better than our whole suite of old Fortran tools, including Opus and Opus projects and our coordinate transformation tools. Go ahead. And we're going to talk more about each of these things later. So what's it going to look like in the future, right? It's really going to revolutionize professional surveying. We're going to have a system that is more accurate, more accessible, more consistent across the entire country. We don't need a benchmark. You don't need to go find a benchmark and survey off of it to get to, bring a height in or a position into your area. You can get GPS, and by following our standards and guidelines, you can get geodetic control where you need it using GPS. As I mentioned, the whole thing about the water levels and the river systems, and basically that consistency of the elevations is going to vastly improve floodplain mapping. That's in our socioeconomic benefit study. That's really where a lot of the benefits going to lie, is really in those increased accuracy and consistency of heights across the country. It's going to have impacts on infrastructure, right? If you're building things that, as I said, that go over the horizon, anything requiring precise positioning is going to be, you're going to have better tools to do that. So it's more efficient, saving, reducing duplication of effort, saving money by doing it right the first time in many cases. And then fundamental support for new technologies, right? We're talking about smart cities and smart cars, right? You don't want this autonomous semi-truck that's driving on the highway next to you needing to do a datum conversion while it's trying to pass you, right? We want to get this system in place so those new systems and that the technology that's coming can really take advantage of it. Go ahead. All right. So every latitude, longitude, and height will change from its NAD83 values in the plus or minus 2 meters range. Every orthometric height will change from its NAVD88 height in plus or minus 2 meters with an unknown limit in other places. As we said, we don't know how things have changed in a lot of places that are moving unless somebody has actually been out there surveying and measuring how things are subsiding or uplifting, right? Rather than having a published coordinate at each core station, at each of our continuous GPS stations, we're going to have not just one coordinate, we're going to have a coordinate function. So we can show how that station moves over the course of the year through the seasons and all the effects that weather and environment have on the position that GPS computes. We're going to have coordinate functions at each of our stations to help add in that time element for our stuff. And then greater integration, right? One of the things I didn't mention was NAD83 and NAVD88 were two completely separate systems, right? They were two separate survey parties that never the twain shall meet. You had your leveling crews that would walk across the country. You had your Bilby Tower crews that would, for NAD83, that would build these big towers, and they would build their systems separately, right? The new system is designed to work together. And there's a whole bunch of benefits to that, but it's going to really reduce confusion and improve consistency across the system. All right, you can click through this. So GravD, Gravity for the Redefinition of the American Vertical Datum. It's been going on since 2007. 15 million square kilometers of data collected, almost 5,000 flight lines, 2.3 million kilometers. We've been up there flying airborne gravity for most of my career at NOAA. Right? The final data set for this huge project was just sent to our geoid modeling team in February. So we've just, that's a huge accomplishment gotten through in terms of being able to be on course for completing the new system in the near future. Good. So Geoid 2022 is something that we've been working on with our international partners, particularly in Canada and Mexico, since 2014, iterating through using the improved modeling technologies, using the new data from GravD as it came in. We've been computing what we call experimental geoid models for the last 10 years. The last experimental, and the experimental, right, as opposed to the hybrid geoid models, which give you NAVD88 heights, these experimental geoids were practice iterating towards this Geoid 22 purely gravimetric geoid model. So the alpha version of that, just the data and a lot of the grids are out there for Geoid 2022 now on our alpha site. That's really just for sharing with international partners and some folks that really know what to do with it. It's not supported with tools and things yet, but we're getting there. It's out on our alpha server. And then GravD completion, we're looking at, that was in February, and then, so we're looking in July for the first iteration of Geoid 22 to go to beta, for beta testing. Okay. All right, modernized access, and I think this is my last slide. Access to the new system is going to be through the CORS network. Actually, there's one more after this. CORS, our continuously operating GPS reference stations, and OPUS, our online positioning user service. So people go out there, collect their GPS data, they can submit it to us through our tools. We will use the data from the CORS to correct it and give you back a more accurate solution. As I said, each one of those stations has that coordinate function, and then the software is being updated and improved. And we should, for some of these tools, have multi-constellation in the future, meaning not just GPS, but GLONASS and Galileo and the other countries' GNSS, or Global Navigation Satellite System data. Next one. All right, I think this is my last slide. So the NOAA Foundation CORS network is what ties us to that international terrestrial reference frame. The Foundation CORS are the main, the doubly redundant systems that, they're operated by us. They're high quality, highly reliable, and these are systems to guarantee access to the National Spatial Reference System. And this is, I mention this because the CORS network, there's 2,000 plus, around 2,000 stations. That's a partnership network. People put those in for their own needs. We serve up that data, but we don't, maintain those. And we can't necessarily always ensure that the data is the best. With these Foundation CORS, these will be ours, and these will also be used to compute the ITRF systems, so we will have that consistency with the international system, and it'll be our foundation for our CORS. So with that, I'm going to turn it over to Charlie. Nope, I'm not. This other guy, Dan Roman.
Hopefully you can hear me on the recording, and then hopefully everybody in the room can hear me. Galen got to play cop. I guess I get to be bad cop. No, nothing quite that extreme. So I'll ask you in the room, and maybe people online can think about it too. How many people still use NGVD 29 and NAD 27 or earlier models? The reason I ask is because it's going to become very noticeable. Galen highlighted the fact that we're looking at like 2 meters of difference. These things, they're starting to get that extra frequencies on there, and you're going to actually get down to this type of positioning. People are going to notice that you're in an antiquated reference system, that your coordinates aren't necessarily fitting, and that you don't meet those future needs. So in terms of the why you should care, there's that component of it, but there are some other programmatic ones that I'll talk to as well. So next slide, please. So we'll start big and go down small. So the UN, other countries are moving to this. As Galen noted, this is the international terrestrial reference frame that we're tied into. We are tying the national system into that. The motivation is that we basically have all of these different activities going on. As you look at the image to the right, you can see commercial, you got all the economic activities, you got environmental, all these different things that are going on. They work better if whatever we're measuring and observing in the United States is consistent with what other countries around the world are doing. particularly if you're looking at like ocean matters or things of that nature. And it doesn't have to be just scientific and looking at climate change or any of those types of issues. There are plenty of economic indicators that, if you have a ship coming in, comes through on the same system, pulls into the nautical waters of the United States, comes up the river, pulls in pier side on time, all in one system, that makes for efficiencies in the economy. So there's a lot of motivations here beyond just the scientific and let's get everything coordinated. But as Galen also mentioned, we're working closely with the Canadians. We're trying to make sure that the reference frame in North America is the same in Canada and the United States. And as much as is possible, Mexico and some of the other regions as well. So there's plenty of international collaboration going on. The IJIF is a template that has been generated that basically helps countries scope how they're going to devise their infrastructure. So there's something called the National Spatial Data Infrastructure, which is all things geospatial. And geodetic components are underneath all of that, but the NSDI is the principal thing that devises how the government is organized in terms of all of the geospatial activities. The IGIF is a template that tries to help countries that are developing countries to try and work through that, but it also is there for developed countries, such as the United States, to try and figure out how they're going to formulate their strategies as well. Next slide. To that end, we had a law passed back in 2018, the Geospatial Data Act, which basically codified a lot of the things that were in that IGIF and some of those other UN agreements. In the GDA, it basically put in force something called the Federal Geographic Data Committee. Now, the FGDC had existed for quite some time, but now it basically has the imprimatur of law in it. It is codified in the US Code. It is now sanctioned as the organization that's supposed to organize all geospatial activities. And along those lines, they have a lot of information that they pull from different agencies, but and a number of working groups underneath, one of which is a standards working group. And if you actually read GDA, it says, where possible, abide by international norms and standards. And then they also require audits for the departments. So you get your department level auditors coming down and checking all your geospatial data sets to see, are you in conformance with this law? Are you following all the standards? Are you doing the things that were required by the law? And that becomes more significant as I get into this, as you'll see. The big thing to take away is that the FGDC is comprised of these SEOGIs, Senior Agency Officials for Geospatial Information. A SEOGI can be a GIO, a data officer, a data manager. It depends on the department, but the bottom line is they're going to be the ones that are sitting on this committee designed to try and coordinate all of these activities across the whole of the government. So next slide, Charlie. So these are the ones that are listed. Now you notice there's only about 31 and about half of them are vacant. I would also ask you to look, do you see your reps up there? Are they vacant? These are not going to be anybody in this room. These are going to be senior level officials. But if you don't see them up there, if they're not sitting at the table, then they cannot represent your points of view. And this group will make decisions on standards that the rest of the government has to live with. So if you're not sitting at the table, you don't get to vote on trying to determine which standards you're going to have to abide by or how they might be crafted so that you could adopt them more easily. So again, if you don't see your agency represented up here, Josh Delmonico is the director for the FGDC. I would urge you to go to fgdc.gov and look to see what's up there. You talk about the Geospatial Data Act and they talk about a number of other things. So again, this group is going to make decisions that affect everybody in the government on geospatial data. If your group isn't represented, that could be a problem for you. Next slide. So then, motivations again. So we talked about GDA and the FGDC. Biggest one to take in here is, as a part of the GDA, is the limitations on the use of federal funds. So that says that once the FGDC sets standards, which so far they haven't, but they're probably going to do it soon, then the clock starts. 5 years after that, Congress reserved the right for itself to go in and start taking agency funding and limiting its use. In other words, if you're not abiding by the law that they passed and the available standards that you've been told to abide by, and you can't prove that you are through audits, then you might lose federal funding. That's the hammer. So that's the part I want to make sure everybody understands. There are programmatic aspects of this that people need to pay attention to and take back. Again, I don't expect anybody at this level, none of us are really at the tier where we can make decisions on this, but if you have enough information, you can go up and you can influence. You can find your GIO in your organization, make sure that your interests are represented and see if you're on track. The one thing you can do is make sure your geospatial data is on track. So then we talk a little bit about GeoPlatform. One of the requirements is that we make the data findable, accessible, interoperable, and reusable, fair. Next slide. So GeoPlatform is the way that the US government envisions doing that, at least for special data sets called National Geospatial Data Assets, NGDAs. So we have 4 NGDAs. We have the NOAA Cores Network. We have geoid models. We have the gravity data, and then we have our. Those are the data sets. Those are NGDAs. They help others do their positioning, but they in turn are also geospatial data assets that have to abide by these same rules. So we have to make sure that all of these go up on the website and are maintained, but in addition, then we also have to use these to help others leverage their data sets and make sure that they're in compliance. Next slide, please. So then, underneath the FGDC are a number of working groups and subcommittees. And to go alongside the geodetic control theme, there's the Federal Geodetic Control Subcommittee. Not a real surprise. These are the members, the active members of the FGCS. Again, do you see your organization up there? I know Larry shows up on a regular basis, so I'm good with him. But the question is, what about the rest? Do you see your agency up there? The FGCS's function is more at practical implementation. We've got the control, the data, that's great. But how do you use OPUS? How do you follow? What standards do we need to develop? How are we going to implement all of this? The FGCS is where a lot of that coordination would occur. And they're also going to be the body that will vote on this eventual switch to the FRN. We'll get to that a little bit later. But this is the group. Again, if you're not sitting at the table, you can't play. So again, I would encourage you to contact Galen. I'll throw him over the bus. But contact Galen to join if you are not already seeing an organization up there. If they are up there, you can contact Galen and find out who has been going to the meetings and represent, because he may be representing his portion of your agency and not necessarily your interests. So again, I encourage participation here because this is where a number of the practical aspects of how the modernized SRS is going to be implemented will at least be discussed, if not actually worked out. Next slide, please. So then finally moving on to, now that we've discussed how the programmatic aspects, we'll talk about what we're looking at from a broader perspective. So we do have 3 blueprints up. The first talks about the terrestrial reference frames. The second is geometric. And the third are case studies and practical, what's it mean to you type of questions. I encourage you all to download, take a look at them, try and understand them. They can be a little dry, I admit, but particularly the blueprint 3 is where it comes into case studies that talk about how this might impact you, what steps you might need to take. And this is the part where I think it becomes of interest for you. And, you know, in the end, there's a number of different things. It's all about what we're talking about, the different data sets, how you use them, the different tools. But there's procedures and everything, and then it's a question of what do you need? And we'll get to that, and I'll reiterate it several times. I can't tell you what your requirements are. You have your data, you have your mission, you know what your requirements are in terms of precision and accuracy. We can tell you what tools will work to what at different levels, and some are easier to use than others, and maybe less expensive than others. But in the end, you have to know what your case is, what your metadata is, what all your data are, how you access it. That's something you have to determine. And this is for everybody. They have to understand their own data sets and their own requirements. Next slide, please. So then, rollout testing. So, as Galen touched on, we've already got like alpha model out. We're working on beta models. The goal is to try to have them all out in the 25 range, or actually through 24, with 25 being the testing. So we want them out. We want ample time for everybody to look at them. We want those models out. You can run your data through. You can test it to see if your business flow models work, if you could use those tools to actually do your work, if you can migrate your data, whatever your mission might be. We want to make sure that there's appropriate tools to try and address those concerns and make sure that you can operate in the new system before it becomes final. So testing will continue for at least 6 months after we fully kind of get it rolled out. And it could go longer if there are issues that arise. The goal is that before we really even go back to that FGCS body and say, okay, we need a vote, we should have addressed the major concerns at that point. We should really have it in our minds that, yeah, we've got this sorted out. At that point, then we start talking about a vote and an FRN, and then sometime after that, it'll become official. So for now, though, the initial rollout is going to be limited tools with excellent coordinates. Not going to get everything out that we wanted, but we modernize the data with the most critical components of it and the tools that are most likely going to be the ones that you need. So next slide, please. So the current, during the rollout and all this testing that I just described, NE83 and NEVD88 still are the current datum. So everything you do needs to still abide by whatever requirements you have for the current NSRS. So that doesn't go away until we actually do finish flipping the switch, but that's, as I said, it'll be down the road. But right now, the big takeaway is, we talked about ITRF 2020. For those who don't know our workflows, we actually take all the GNSS processing we do it in the ITRF. It was 14 before, now it's 2020. Then we go back to ITRF 96, and we make a fixed transformation to NED83, which is one of the reasons why we're moving forward to just adopting ITRF 2020. But for now, ITRF 2020 is in the process. So if you collect your data, we do the post-processing on the orbits, we do the calculations, and then we move it back through over almost 20, 30 years to get to a fixed point where we have a standard transformation to NED83. And that will continue. But we already are implementing ITRF 2020 is the key takeaway here. So then when we make that next step, we move to NatRef and all the other models, we've already established that we're doing ITRF 2020. That won't be a heavy lift there. That's already accomplished. Next slide. So snapshot, we are looking at ITRF 2020. So if you put in, submit your data, you say you're not just processing grids of data and you say you want to go out and collect new data, you'll submit your data, it'll give you that coordinates in ITRF 2020. It'll give you a snapshot of at the reference epoch coordinate in each of these datums, which is currently 2020.0. And then you also get geopotential values and everything else. The key difference here, and Galen touched on it, the geometric coordinates are the entering argument. It is no longer treated separately. It is a coordinate reference system, geometric reference system, with a geopotential datum inside of it. So we will take those those geometric coordinates and directly determine the geopotential surface, the geoid, dynamic height, orthometric height, whatever you're looking for. But those will be exact. That is approximation. That is not gridding and trying to come up with the best fit. It is by definition the surface. So part of that will be continued testing to make sure that we have the best model. And that's where the dynamic components will come in later. But yes, we will have reference epoch coordinates. Static will have multi-GNSS, and the OPUS projects will still be GPS only. So this is where I was saying there were some things that we just did not get to and we're not going to be able to get to till after 2025 rollout. And then we'll continue to refine things and add in new features as time goes on. Next slide, please. All right, testing into replacement. From 2025 to 2026, I touched on this a little bit. The process is we're going to go through it. Once the FGCS votes, then the FRN is issued, and then at some point we will flip, and the modernized NSRS will be the current NSRS. Now the thing to keep in mind, if say you submit data, and I think it might be on a later slide, but if you submit data in for testing during the beta period, do not assume that it will be propagated into the final one. We might just wipe the slate and just set up the new system because it's different servers. So we don't necessarily migrate the data. So I would encourage you to keep your data, your observations, whatever you submit. I will always encourage that, and you'll see that later. But for now, the idea is that once we get to where we've made that official switch, then we will no longer support NED83 and NEVD88. There will be no longer that whole work stream that has been supported for the past few decades. Next slide. Okay, starting to run a little long. Okay, preparation steps you can take. We talked a little bit about this. Everybody's situation is a little different, but NGS has 5 different things that you can try and support on your web pages, or on our web page. So this next slide. The biggest thing is your metadata. When did you collect it? What datum? What corrections? Anything you have about your data, not just a latitude, a longitude, and a height. Again, datum is like the whole left-hand business. When you measure something with respect to what? A datum is a point of reference. It is the floor. If you're measuring how high above this thing, that's great, then that's your datum. If you're measuring above the floor, then that's great, but you get two different measurements to this exact same spot. Your datum is critical. Where are you measuring from? And there can be significant differences, and those can be confound things when you're trying to stack them into the same system. So this is part of that interoperability piece that we talked to. So how is the data collected? How processed? As much information as you can collect. And this is the way we're trying to get out now. You need to go back and look at what all your requirements are, what your metadata is, and look at your data and start thinking about what you have. Then we can start talking about how you're going to migrate. But for now, start digging in through, seeing what you have in terms of these requirements. Next slide, please. So continuing on then, perform GeoSpatial benchmark campaign. So Galen kind of touched on, we kind of finished GeoID 18, so that's done. And that is the last hybrid model we will do. However, you can continue to collect data. If you save water level stations, we can calculate where they are in NAD 83 and NAD 88 right now. But if you keep the data, then when we switch to the new datum, you can reprocess it and it'll be in NatRef and NapGD 2022. So you don't have to necessarily go out and resurvey the data again if you've kept it and you have all the metadata and everything associated with it. So those are the key components there. Just keep in mind, we encourage you to go out and continue the collections, because it's not like you're going to be able to make them instantaneously. If you got a schedule, a work schedule where you can get out and you can collect the data, just keep it and archive it, maintain it, and then when the time comes, we can help you move that forward. Next slide. Tab through a couple. Okay, so 3 approaches, 3 different levels of confidence in terms of the results. So obviously resurvey, okay, go out and collect new data. Well, yes, that will probably get you the best result, but you just had to plan a campaign survey, go out, collect new GPS on all your benchmarks. There might be some costs associated with that. It depends on if you already do it regularly or not. Again, I don't know what your requirements are and I don't know what your workflows already are. But there's a cost associated with going out and doing resurvey. Readjust if you kept the data from the last time. You don't have to go out and recollect it. Remember, when we do these adjustments, we actually calculate the orbits of the satellites all the way back 30 years. So if you observed something 10 years ago and you still have the data, we can tell you where the satellites were in the new system, in ITRF 2020 and NatRef from 10 years ago in the same system. So you can reprocess it. You don't have to recollect it. You can't from 10 years ago anyway, but you can keep that data and you can maintain it and move it forward into the new system. So that's a little more cost effective. It's not as good as, because the Earth, is, that Galen mentioned, is moving. It's still not as good as reobserving it, but it's still pretty decent. And then the last is transform, and that is doing a grid type transformation. So if you have gridded GIS data, that's probably your best bet. If you're good with decimeter level errors associated with a datum transformation, that's going to be the easiest and the lowest cost, but it's not necessarily going to give you the most accurate results. But again, it depends on what your workflow is, your mission, your requirements. Next slide. So just talking about these a little bit more, resurvey, readjust, and transform. The different tools that you would use. You go out, you have to plan a field survey if you're going to resurvey. If you've got readjust, then you can just take your data that you already collected and reprocess it through Opus. And then finally, NCAT and VDatum are the grid transformation tools that would enable you to just take grids of data and just change out the datum. I mean, it's literally from NAVD to NapGD 2022 as a layer in a GIS, and you just apply it and you've shifted datums. That should be pretty straightforward. But again, with varying degrees of uncertainties associated, depends on your requirements. Next slide. And continuing. So, as we mentioned, Opus 6 is the one we didn't quite get to that we're going to have to try and finish up. But Opus 6 would adjust not just multi-GNSS, GPS, GLONASS, and all that. It would also do the leveling and gravity and. So that's what we really wanted. We want to get to that. But right now, the Opus 5.x, we'll say right now, those models will do the GNSS transformations. And those are going to be the ones that are going to provide the engines for the transformations and providing us information for when we roll it out. So we'll have that available. We'll see if we can get, like I said, we want to get this out Then we'll work on finishing up Opus 6.0, because there's a lot more that goes into that one. It's not just adjusting geometric data, it's the leveling and gravity and a lot of other information in the software. So we will look to do that, but right now you'll get your coordinates, as I say, and the 4 models with a geoid, and then the abilities for state plane projections as required. Next slide. Transform, again, grid transformations. Input your current datum, output datum you want. It does the transfer, it calculates a grid for you. You can put in a bunch of points that are on the same grid interval as your map. It can spit out a layer that you can apply as a GIS, and you're done. That's pretty straightforward. But there are errors associated with that because what went into making that transformation grid, usually in the decimeter range of errors. So if that's acceptable to you, then this is definitely the easy answer. Next slide. And again, transformation tools, where they're located. You can find tools on our website, and you can find NCAT, and go from there. Next slide. Alpha, beta, official. So anything that we produce that's official is going to be geodesy.noaa.gov. All our production stuff is there. And that's where the current NSRS will stay until we flip the switch on the modernized NSRS. In the meantime, beta.ngs.noaa.gov is where the beta versions will reside. Once we've blessed that, then we will move that over to production side, and we'll move the actual current NSRS to a different location. We'll take it off-site. But again, and then we do have alpha, some early stuff. A lot of the developers wanted to get an early look at Euler pole pipe parameters, different things that they can start to program into their coding. That's where we put them up on the alpha site so that people can pull that down. But the more complete tools will be on the beta website, and we encourage you to look there for your testing.
Well, good afternoon. I'm Charlie Gohagen. I am the third speaker following Dan, and that's going to be a tough spot to follow here. I've been with NGS since 1970. Literally started at the bottom and worked my way up. I was on a building crew for Bilby Towers. That's where I started. And here I am today, the regional advisor for the Mid-Atlantic states, which includes Maryland, DC, Delaware, and a few others. Also Puerto Rico and the U.S. Virgin Islands. So we are real excited that we're getting a new geopotential datum that will not only cover the contiguous United States, but also the Virgin Islands and Puerto Rico. So let's go ahead and get started. I'm part of one of 14 regional advisors throughout the United States. We all have our areas, and if you can look up here, you'll see that these are what we like to consider the eyes and the ears of NGS. We not only speak about what's happening at NGS, we also listen to any questions or concerns that our constituents have. So if you're not familiar with the geodetic advisors in your area, it would be good to get in touch with them. They're very friendly people, and they're always open for questions and answers. In addition to that, we have 39 geodetic coordinators throughout the states. And these geodetic coordinators are basically work within a single state, and they represent the concerns of that state to NGS. And so they work hand in hand with the geodetic advisors to let NGS know what's happening with them, with their state, and how we can help them. And that's what NGS is. We want to help everybody who needs help with the new datums. And I think that's what Dan and Galen has emphasized earlier today. Next slide, please. The NGS mission to define, maintain, and provide access to the NSRS to meet our nation's economic, social, and environmental needs. I think that's a pretty important mission, don't you? One of the things that I'm emphasizing in my talk today is going to be access to the NSRS, okay? We have tools, and Dan had mentioned these tools earlier. I'm going to talk a little bit more about them. We have Opus Static. Basically, it's a single point solution system. It actually we'll use the 5 closest, or find the 5 closest NCN, NOAA CORS network stations, and it will determine which of the 3 best are of those 5. And it will come up with independent solutions of all 3 of those, and then it merges those together to give you a final solution, and it gives you some estimates of accuracy. To improve upon that, we have OPUS projects. We have OPUS Projects 5.2 right now, which is the latest version. This is for if you want to do campaign-type surveys. Now, let me tell you, a lot of people are kind of afraid of these campaign-type surveys because of the cost that's involved with them. But as a lot of my people that I've talked to will tell you that it's not really as bad as what you might think. And to top it off, with OPUS projects, now we're able to streamline our observations right into the NGS IDB fairly easily. It's not like it used to be. We can now use or bring in real-time kinematic survey vectors, which is something we couldn't do before. We bring them in with a format that we've just developed pretty recently called the GVX format. It is an XML type language, and it's one that has been introduced or adopted by a lot of the industry. And so if you use their products, they will actually export a GVX file for use in OPUS projects. We can export the various adjustments in various formats too, which is something that is fairly new with OPUS projects. Dan touched on OPUS 6. That's our next big version, and it's going to be a doozy. It's going to be revolutionary because if you are familiar with NGS and how we accepted data into the IDB in the past, there was a time when we would take angles and distances from total station type instruments, from theodolites and EDM. But then there was a period where we stopped doing that because it got too expensive, too costly for us. And we focused on GNSS, GPS mainly. But now we're going to move back to the point where we will take that data in because we've learned that people who provide the data are not just going to provide it in one observation type. They're going to provide it in GNSS, and they're going to be out there using their total stations to make observations on their sightings on their points also. And we're going to be able to take that data and combine it, apply the appropriate weighting to each data type, and provide an all-encompassing adjustment. And that includes leveling data also in gravity. We're working on a new leveling manual. I'm part of the team that's working on that down in Corbin. We got 3 or 4 people that are very experienced in leveling, and we're going to be coming up with the manual that, as Dan was telling you earlier, we're going to be accessing the NSRS, the NAP-GD 2022 through GNSS, through the NOAA CORS network. So that's going to be an exciting time. And I've said this before to people, this is really a very exciting time in my life, because when was the last time we had a datum change? It's been a while, right? It's going to be something to remember. And this datum change, this new NSRS, this modernized NSRS, is going to stand for a good long while. They're putting a lot of work into it. And there's also a tool that we have called Locus, the Leveling Online Computation User Service, where if you go out and get your leveling data, you don't have to submit it necessarily to NGS to get an NGS adjustment. We've got this service now that you can upload the data, and it will give you an adjusted, very similar to what NGS would provide, and it gives it to you almost instantaneously. It's going to be used until we can get OPUS 6 out, where we're going to be able to bring leveling data into the new modernized NGS, or NSRS. Next slide, please. In addition to what all is going on at NGS, we are providing, and that Dan and I think Galen both have alluded to, the state plane coordinate system. We're updating that. Basically, the whole, the entire new system, NSRS, is going to be able to be projected to the states. Everybody's going to be on the new system, the same system. And this is good news for actually the District of Columbia, which before did not have a state plane coordinate system. And now, in the past, they kind of piggybacked off of Maryland, which is fine. But in this new, in the new modernized NSRS, they're going to have their own state plane coordinate system. Projections are really important. Most of the people I talk to use state plane coordinates. They use these projections, and they're used very heavily by the state highway departments. I can tell you that. Next slide, please. NCAT, Dan talked about that. So this has been kind of a big deal. Before we had several ways to get around to going from one datum to another datum for doing transformations, for doing conversions, and all that's been combined into one, the NGS conversion and transformation tool. Next slide, please. So here's what we have, and if you want to just kind of punch through the next ones. This is some of the things that we had to go through in order to, the tools that we had, individual tools, independent tools that were used to go from one datum to another, one realization of NAD80, another realization. And what NCAT has done, next slide please, is it's combined all these. Go ahead and punch through it. I think we've got some arrows, yeah. So we can go through each one of these in one tool, and we can get all the way up to the NatRef 2022, or the geometric reference, the new geometric reference frame. And I want you to notice one difference here. If you look at all of the NAD83 pictures up there, the XYZ coordinates. Well, what's going to be different about 2022 is those XYZs are going to be aligned to the International Terrestrial Reference Frame. And that's what Dan and Galen had talked about. That shift is going to be extraordinary. It's going to put us in world-class area. Okay, next slide, please. Next slide, please. Okay. NGS products update. This is a screenshot of what NCAT is. If you look at all the options that you have up there, you can go from horizontal, you can go horizontal in height, you can go geodetic, lat long, state plane coordinates. You have all these options all in one tool. And they'll give you a solution, actually quite an extensive solution, a nice report in any of the outputs that you want. Next slide, please. Tools available in 2025 in the rollout. We then talked today earlier about rollout. That's going to happen in next year. It's going to come out in beta on our beta server, and it's going to reside there for a good while. So right now, if you go to our beta server, you'll find some tools there, some applications. Those are kind of going to go away, or they're going to go up to production. But beta is going to be reserved for our new NSRS modernization tools. We've got a new least squares adjustment program called LASER. I like the name of that, LASER. Sounds real scientific. But anyhow, that's the acronym that we're using. It's going to be replacing the things, which is something that we've been striving for at NGS, is to combine things together to have a more uniform solutions. And it's going to properly weight different observation types. I said that earlier. So if you have leveling, gravity, angles and distances from total stations, all that's going to it's going to be weighted properly If you have messed with GNS data at all, it doesn't matter what baseline processing software you're using, with some very optimistic estimates of position. And those don't, you can't use those, say, with leveling estimates of accuracy or total station estimates of accuracy. So they got to be weighted, have the appropriate influence on the adjustment. And finally, we're going to have, we're going to be using C++, which is something we're going to get away from Fortran, which so many people at NGS loved. Next slide, please. The laser will be the engine for Opus 2. It'll be the adjustment engine for Opus. So in our effort to bring in all these different observation types, we're going to have one file type that's going to be able to satisfy all these different observation types. It's going to be called GDX. In 2021, we developed GVX, and we got a lot of support from industry on the GVX, and they were able to incorporate that into their software. We've already got the message out that we're going to be using GDX. We're going to be not only using GVX, which was basically GNSS. In GVX, you're able to bring in any type of GNSS vector and then eventually bring that into projects. With GDX, that's going to be the format we're going to be using, that we can bring in all different observation types. So for the time being, when it first rolls out, and we're only going to be able to accept GNSS observations, that's one of the delays that we're going to have is to accept other types of observations. But when we first roll it out, you'll still be able to submit data through GVX, and internally we'll convert that to a GDX. So until the vendors and private sector catches up with us, we'll still be able to accept GVX. All right, next slide. Common grid format. This is something that happened not too long ago. US and Canada agreed on a common reference frame grid format, which is something that I think it's just a good example of how nations can work together, especially nations that are so closely tied as Canada and the United States, to actually come up and agree on what's appropriate for both of them. In the meantime, the format's going to be called GGF, Gridded Geodetic Data Exchange, and we've already started moving a lot of our data over to this format. The format could be JSON or NetCDF or a number of other different formats. So, this is going to be a common format that will be used by the different countries. Next slide, please. Dynamic heights from GPS. Currently, we have a relationship between these heights that works with, in NAVD88, it works with geopotential numbers, establishes those, and from those geopotential numbers, we'll get dynamic heights, and on the other side of that, we'll get orthometric heights. Then we'll apply a geoid model. The geoid 18 is the current model, like Galen was saying, and with that, we can get the ellipsoid heights. Now, in the modernized NSRS, we're going to be working it just a little bit differently. Remember, we're going to be using GNSS to tie to the new NSRS, the modernized NSRS. So from GNSS, we get ellipsoid heights. And with the ellipsoid heights, we're going to use a really good geoid model, geoid 2022, I suppose, what it's called. called, right? Geoid 2022. We're going to use Geoid 22, and we're going to determine what the orthometric heights are from the ellipsoid heights. And then from the orthometric heights, we're going to use a gravity model and move over towards the geopotential numbers. So it's working a little bit backwards, but it's going to be a much better system. It's all going to be tied together much more closely and tightly. And then from the geopotential numbers, we can go to the dynamic heights, which is used widely on the International Great Lakes Datum. Next slide, please. Reference epic coordinates. We're actually pretty used to these, although we don't call them reference epic coordinates necessarily. But in NAD 83, we're in the 2011 realization. The reference epic coordinate, if you will, is 2010. So that's 2010.00. So that's where all of our coordinates in NAD 83 are referenced to right now, that epic coordinate system, or reference epic coordinate. In the new system, we're going to be starting off, we're going to align with the ITRF 2020, and that's going to be our reference epic coordinate. Starting off, it's going to be 2020.00. As we move on, well, in the geometric system, which is the NatRef, PatRef, CatRef, all the AntRefs, we're going to be using the XYZ coordinates, and those are going to be converted to lat long and ellipsoid height. Big undertaking. We got 120,000 marks, 630,000 GNS baselines, and I've been working with the REC crew to get those changed, or to get those updated so that we can get those into the new NSRS. The constrained coordinate functions, Galen was talking earlier about functions, not positions, will be in ITRF 2020 at the epic date of 2020.00. Only those stations that actually existed had good data at that epic date. The orthometric side, we're going to have the NAPGD 2022, the North American Pacific Geopotential Datum of 2022. The epic date is going to be, again, 2020.00. And this is one of the points that I think we need to drive home, is that these two systems, the geometric and orthometric, are tied together. And that's what Galen was saying earlier. In the past, we had horizontal on one side, we had vertical on the other, and never the twain shall meet. But now, with the new modernized NSRS, they're going to be tied together. They're going to be both using the center of mass of the Earth as a starting point. So there's a big process there, and they're well underway. They got about 960,000 marks, 2.1 million kilometers of leveled height, or 200 leveled height differences they're going to be bringing in. And the final data pull is probably not April 2024, but it'll probably be at least probably next month before it happens. So if you, the key here is we've got right now in the works, we've got people who have submitted projects, and we want to make sure that those, and they're being reviewed right now, we want to make sure that those projects that are currently in the pipeline get processed and published before we make the final data pull. Still expected early results is late 2024. Late 2024 is December. Reference epic coordinates. Okay, so we got geometric, we got epic 2020, that's what we talked about. ITRF is going to be 2020, that's where we're starting. It's just going to be tied, it's going to be basically the same thing at that time. All GNSS and classical observations are going to be put in there. I happen to be one of the ones in charge of bringing out the classical observations that are in our current integrated database and making those available to the new NSRS making them available to LASER, which is our adjustment program, so that we can have a national data adjustment. and I hate to say that it's a big job, and I'm not there yet. Working on it. So we got the orthometric side of it. We again 2020 NAPGD 2022 all leveling observations. Basically, the bottom line here is that we're going to go from our geometric, and we're going to create orthometric and dynamic heights using the data from the geometric adjustment. And that information is going to also go into the orthometric height adjustment. And you'll see that, that's how the two are going to be tied together. So you're going to have information from geometric going into orthometric adjustment, and then in the end, we're going to have ellipsoid heights and dynamic heights from that. Next slide. NADCON 5.0. NADCON's been around a long time, North American datum conversion program. Larry probably been very familiar with NADCON. It's embedded in a lot of software, not just NGS software, but user software from the outside in the private sector. And you'll see that this is going to enhance NADCON. It's going to be able to go from, and Dan was talking about the transformation. This is what NADCON does. It's going to be, NADCON is going to be embedded in NCAT. So you won't have to run NADCON 5.0 to get from NAD83 to the new reference frames. But it's going to be embedded in there. And that's what the importance of NADCON. If you're interested in finding out more about NADCON, there's a link there. Next slide, please. VertCon, of course, as the name implies, we are going on the vertical side. VertCon, both NADCON and VertCon worked with the old datums to bring everything into NAVD88 and NAD83. We're updating them so that they'll be working a little bit differently. Like the previous slide showed, we're going to be able to go from NAD83 to the new reference frame in NCAT, and VertCon again is going to be embedded in there. I was surprised when I was doing some research at the number of industries, the private sector companies that actually incorporate these in their software. Maybe I shouldn't have been surprised. Next slide, please. The data delivery system, that's going to change a little bit too. We've got right now kind of like if you pull up a data sheet for any of the points in our database, it looks like a piece of paper with a lot of stuff on it. It's not very pleasing, not very appealing. So we're going to be doing some updates to that. Before we had two completely different ways to view different types of data. We had passive mark data sheets, and then we had cores data sheets. And they were kind of disjointed. If you went to one page, then you had to click on several different things to get to the point you wanted. But we're going to be modernizing those. They're going to have a lot better look, more appealing, and be more informational in the long run. And you'll be able to get the data that you want to see, not just what we want you to see. There'll be some more flexibility with it. So there's the address. If you want to look at the beta cores station pages, next slide will show you an example of what the cores for one LSU is. That's down in Louisiana. And you'll see over here, it gives you a nice little map and then tells you the next 5 closest cores. And over on the right, it kind of gives you some information that you might have had to go to different sources to find. For example, the station installation date was something that you found in the station log. It looked like an ASCII format file. And when you pulled it up, other information there that you would have to find in other places and bring it together. But these are things that a lot of people asked for. They wanted it right up front where they could see it. And next slide. This is the next picture. The photographs are right there. And this is just scrolling down sequentially through the web page. There's a lot more to it, but this is where I stopped because it would just get a little boring if I just kept going down through this slide after slide. If you look over on the right, this is information that you would have found in the station log, but you would have had to pull that up separately. And this is important information. I know that I've looked at this myself on several occasions and had to go to the station log to find it, and it's not always the easiest thing to do. This is a nice little format here. There's some. Anyhow, it's in beta right now. So what beta means is that if you want to go in and look at it and make suggestions, we're here to take your suggestions and you can make improvements to it. Anything that's in beta is open for comment. All right. So I just want to stress that. Please visit if you want to and see what we have and make comments to us. There should be a link where you can actually email your comments to the appropriate persons. Next slide, please. Dan was talking about earlier that we're not going to be able to deliver because of resources. We're not going to be able to deliver everything that we promised in our Blue Book right away. In our Blue Book, our blueprints, our 3 blueprint documents. So we're going to tell you what we can give you, what we will be able to do, and I think the phrase was that we're going to give you fewer tools, but great data. So back up a little bit. The integrating the different types of observation types, that's going to have to wait. That will come out with Opus 6. Full integration of old tools into NCAT and VDatum. So there'll be some things that may not be there right away. But again, we're going to have the tools in beta for a while. Dan was saying 6 months or more. So that'll give us some time to maybe do some catch up too while people are providing comments on what they'd like to see. Next slide. So here's our beta page, speaking of our beta page. And this also is going to give us, and this is the beta page for the projects. Actually, the Opus, just Opus. And so in this particular page right here, right now, we are able to process different types of constellations, the GNSS constellations. It's something we've never been able to do before, but it is in beta. So any output that you get from our beta page, don't take it to the bank. All right, it's good. It just gives you an idea of what to do. So unfortunately, we won't be able to provide most of our constellations in Opus on the rollout. That probably will have to wait till Opus 6. Next page, please. In pages is the processing engine that's built into Opus. And next, can process any GNSS constellation, can be accessed through our beta page. And again, visit the page, give some comments. Next slide. Opus. Precision User Service. Opus S, Opus Static, and Opus Projects are being transitioned from the current NSRS to the modernized NSRS. Both current and modernized are GNS only for now. For now, there's just the Opus Static will have the potential for doing multi-constellations. It's going to be processing in ITRF 2020, basically. It's going to have an output for ITRF 2020. It's going to be using the MPages engine, simultaneous GNSS vector processing. And that's what's nice about Opus, and I want to expand a little bit on that. We were talking earlier, or I was talking earlier about the cost of campaign-type surveys, and one of the costs is managing your data. And Opus projects, if I do say so myself, does a very good job of managing data. You're able to upload data from any terminal, anywhere. So as your observers, the people operating your equipment, collect the data, wherever they are, they can upload it to a centralized location, and you as a project manager can look at that data and work with it. So there are some cost savings associated with Opus projects. We can process, again, the RTK or RTN vectors that can be brought in. Okay, so we got Adjust, which was the Opus project's adjustment engine before. It's going to be replaced. You choose your Epic. You got NatRef, PatRef, MatRef, CatRef 2022. The outputs, we're going to be using a frame deformation model. We're not going to be using HTTP as we did in the past. In fact, HTTP, and after the rollout, will not be a tool that will be available. Opus recommendations and Opus coordinates. Opus project will guide you through the process to help you get a good solution. It'll also have some leniency, some variances that you can tweak, you can mess with. Next slide. Opus 6 will come after 2025. So here's a basic flow. You got your survey data, goes into Opus, and you ask, did you submit your data to NGS? And it's either yes or no. If you said yes, then NGS will use your survey data in the future reference epic coordinate, and if you did not, then your data will not be used in future reference epic coordinates. Again, epic coordinates, when I say that, it hasn't been decided how often we will update the reference epic coordinates. Those will get updated. And if your data is in our new NSRS database, it will get updated along with the in our database. Did you follow Opus recommendations? If you did, then your coordinates are going to be tied to the NSRS. If you did not follow Opus recommendations, of course, you won't be able to say that your data is tied to the NSRS. Do you want to share your results with the world? You're going to still have that option. Right now, we've got a tool called Opus Share that will allow you to share your data with anybody, with everybody. It'll be published, but it's not into our integrated database right now. A way to take the data that is in Opus Share and bring that into, but we're going to have to be careful with it because the observations that are used to share are not as closely reviewed observations that would come from Opus projects. So we get a public URL for this survey, which you can share with anyone, and your results are shown to you on screen or via email only, so you have an option whether you want them shared or not. Next slide, please. Why use Opus projects? Because it's great. Organizes data for multiple occupations on more than one mark. You can do campaign-style surveying. Campaign-style surveying can be 2 receivers on two marks. It doesn't have to be large. It can be the minimum number of points you can use in Opus projects is 1. But of course, it works better for you if you want to use multiple points on it. It performs the least squares adjustment, which is important, and it takes a lot of the guess how you want to set up your adjustment, your least squares adjustment. estimated relative accuracy between marks. It constrains the control. You put a couple of those in your project, and you can actually extend vertical control to other marks in your project that don't have vertical control. It ensures the survey is tied to the NSRS. We can't, I don't think anybody at NGS will tell you that the private sector can honestly say that their work is actually tied to the NSRS. There's a link there, but not necessarily real tight. Submit survey to NGS for review. This is a big step for us because the review process, there's a lot of errors that might be inherent in your procedures, how you and what equipment you used. Very important. One of the biggest areas in GNSS processing is did you select the correct antenna? Because phase. So this is something that we double check during our review. In the end, we provide a data sheet on your information. If you submitted it to NGS for publication, we will be able to provide that information, and it will be stored and it will be updated as the database is updated. I think that's it. Next slide, please. The interframe deformation model 2022. This is something I'm becoming familiar with. It used to be called the interframe velocity model, but it turns out that the deformation model is an accurate picture of what's actually going on. Within, and notice the wording here, it's intraframe, not interframe. So it's changes within a particular plate. Like for example, the North American plate. North American plate doesn't always, every point doesn't always move in the same direction at the same rate. So we have what we call interframe deformation for that. We're going to account for that in the new model. So the IFDM is going to be a very important aspect of the new datums, the new reference frames. At rollout, it will be a conversion update of the existing Trans 4D. In the out years, it will be more tightly interwoven with actual station motion, actual mark motion, and NADCON. Again, when we talk about station, we're talking about cores. When we're talking about marks, we're talking about passive marks in the ground. Next slide. And here's just an example of what the velocity grids that were adopted from Trans 4D, and then the earthquake displacement grids computed from earthquake source parameters. It just gives you an idea of what's going on within a particular plate. You see out on the West Coast definitely how things are moving in different directions out there. And all that's going to be accounted for with the new IFDM. Next slide. NOAA Core's network metrics. Develop a daily quantitative measure, a score of how well the multi-year core solution generated coordinate functions reflect daily solutions in the NCN. Discrepancies, there's going to be discrepancies, unmodeled motion of the stations moving with Earth's surface, it changes in equipment or environment. This makes the quantitative metric values available to Opus and other users. Project status, incorporated in the Opus Core Select and Opus S Beta December 2023, so it's already in use and has been for a little while. So this is going to be something that other source of information that's going to be available to give you some confidence in what's going on with your project. New standards. This is something we've been working on for a while now. Copy of NGS 92. It's going to be very specific on how you will correct GNSS data, what will qualify for the different accuracies. You'll see up here we've got the 3 different levels. We got primary, secondary, and local. If you'll remember, back in the old days, we had first order, second order, third order, that type of thing. Then we went from we got rid of those uncertainties at a particular station. Those were published on the data sheets. We're still going to be using uncertainties, but as soon as we get this finalized and data coming into the new NSRS, you're going to be able to look at this and say, I want a 2 centimeter ellipsoid height, and it's going to tell you everything you need to do to get that 2 centimeter ellipsoid height. So this will help the public in a way that if you know what level of accuracy you're looking for, then we'll have basically a recipe book for you to come up with that solution. Now granted, you have to keep in mind that GNSS is affected by a lot of different things, the signals are, and this information here takes into account or looks at points that were open to the sky. So while it may have some requirements that you have to occupy for a certain amount of time or a certain number of times to get a certain level of accuracy, that may not apply to every station, every point you occupy. If there's obstructions out there, if there's multipath, if there's things that are going on that we can't foresee in these standards, then you may have to occupy a little bit longer or more times. It looks like, and I've glanced through this document, it looks like it's going to be a lot of work in order to get a certain level of accuracy. But in the end, if you want to achieve that accuracy, then you'll want to do the work. A lot of times the people who promote these GNSS products will give you a different answer of how long it's going to take to achieve a certain level of accuracy. And what they're talking about most of the time is the precision of their equipment, not necessarily the accuracy. So what NGS is doing, we're looking at the final product, the accuracy, the position that you're going to derive from the NSRS. And that's why these standards, while they seem to be pretty strict, are actually the real thing. A lot of work has been put into these. Next slide, please. A place close to my heart, the NGS Testing and Training Center. That's where I work. I'm right now in off that window right over there. So we're in Fredericksburg. Yesterday, today, and tomorrow, we're actually in the middle of geodetic level training. I was helping out yesterday, and I was able to take the day off and come up here and talk to you guys. And tomorrow I'm going to go back, and I'm going to do some more geodetic level training. So there's a lot of things that we do out there, mainly and things that NGS does through the advisors and other people. We provide training both in person and online. We do a lot of webinars, mainly, I suppose, for updating updates to the NSRS, providing information to the public on the new NSRS. And also Opus Projects is a big, one of the big things out to the public and we talk about. And training, geodetic level training here, as well as Opus Projects training. We have a schedule, a place where you can see what's going to be on the schedule for classes here. And we've got 140 acres down here, and it's beautiful. So anytime any of y'all want to come visit, please make yourself at home, come on down. All the classes are free of charge, unless otherwise noted. I don't remember ever having charged a class. Maybe I'm being left out. I'll have to check into that. Its mission is to share knowledge and skills and improve the geodetic positioning capacity of stakeholders. You see sometimes we get a pretty good crowd. We get all types of people down there. Yeah, come on down. Next slide, please. We also have, I mentioned we have monthly webinars. We try to get people to talk about different things every month. Mostly it's been about Opus projects. If you don't want to take the Opus projects class in person, you can do it on a webinar and still get access to Opus projects, create your own project, and input your own data. All of our webinars are available online, so you can go back and view them anytime you want to. If you go back and view an Opus projects webinar, I don't think it counts the same as you actually being involved and participating in the webinar. So if you see an opportunity to sign up and you're interested, please do go to our webpage and sign up. Next slide. Our videos. We have a good number of these, and if I had my computer up here and was able to play one of them, I would play the one that best practices for minimizing errors during GNS data collection. That was actually one where we, at Corbin, where the facility, the training center, we actually developed that and of it. You see the 6 over there are not only in English, but they're also in Spanish. Well, 5 of them are. And one over here. Yeah. Yeah, these are some videos we developed in a program called Comet, and they're available on YouTube. Actually, if you go to our site and click on the video, you'll actually go to YouTube. Take a look at these. These are easy to watch. They're short. They're usually 4 or 5 minutes long, and they're pretty easy to listen to and learn from. Okay, next slide. Online learning. This is a little more involved. If you're interested in geology, actually kind of course level lessons that we provide. You probably want to be interested in them before you start it but they are very good. They'll take you through. They start off with a questionnaire that finds out your level of expertise, and then it will take you through the course as you go along. Be amazed at what you learn. So it's like maybe if you've had any remote learning, it's a lot like that. It's self-paced, and you can just pick whatever one you want and go for it. A lot of interesting topics up there. Next slide, please. The tidal datum epic. So we got a new one coming in. This just tells you a little bit about the tidal datums. They're basically based on a data over a 19-year period. The nodes, the moon and sun nodes, all the variances that happen over that period start repeating. So, and not until 18.6 years they start repeating. So we capture that data in a 19-year period, and then co-ops will provide a new tidal datum epic coming out next year, or 2026, I think it is going to be the next one coming out. All right? After 2026 All right. Yeah, I think y'all are better than we are at those timelines. But anyhow, here's some information on it. It's very important. The title datums are going to be also referenced to the new data. Mainly the NAPGD 2022. If you ever go to the co-op now, you'll see have references to NABD 88, and of course, as we knew, the new potential datum is released and brought to existence, then co-ops will have the reference new geopotential datum. Next slide. Points of contact. Brad, you're right at the top up there. We got Brett Howe, our acting NGS Deputy Director, Dan Roman. Of course, now your email is out there, Dan, you can't hide. We got Drew, our Modernization Manager. That guy's got going on, I'll tell you. He's the guy that's responsible for this whole, getting out the whole new datums. Galen, our Constituent Resource Manager. Yep. Y'all get familiar with him because he's got a lot of pull with NGS. Our regional geodetic advisors, and these are all links to the web pages. Our NGS web page, presentation library, publication, webinars, education vertical videos. We got a lot of stuff going on in NGS, a lot of information for the public. So I hope y'all are interested enough to get in touch with us and let us know how we can help you. And that's one thing I try to emphasize when I go and go out and speak is I want people to know that we're here to figure out ways that NGS can improve your life. I know we have a very specific area that we work in, but how can we apply what we know to help you? So don't be afraid, don't be ashamed, don't be afraid to get in touch with any one of us. You notice my name's not up there. All right, next slide. We're down to the use cases, and I think this is where I'm going to cut it off.
So we're going to wrap it up here. We're going to be done for sure by 4:45. And I think it really depends now on the kind of interaction that we want and that we need now. This is kind of an open session. We would like to hear from you all about the data you have and questions that you have. Before we get too far into it, I did want to point out that we got 2 recent articles out in mainstream, the trade journals. This one's the April issue of XYHT, NOAA's New Geodetic Datums. That's a pretty good article by Juan Plaza. Talked to me, he interviewed me for this article, so that's out there. And then I'll click over to another one that is from actually last week, Geo Week News, which is inside the Modernization of the National Spatial Reference System by an author named Matt Collins, who's going to be doing a year-long series of articles on modernization with our geospatial modeling grant partners. We actually have partners at universities around the country that were funded last year that are going to be doing a whole bunch of projects working with us towards modernization. So just wanted to let you know that those things are out there to give you kind of a broader, higher level picture of it. So this session is really about your questions, the data that you have, how to migrate it. So I guess we want to open it up and see if anybody has. We do have some other backup slides here that we can go through, but I think it would be more effective and more interesting for us all if we have some real world examples. So anybody want to? All right.
Okay.
Kurt.
So the question was with regard to the temporal aspects of the datums, and we did touch a little bit on it. Didn't go into great detail. So the intra-frame deformation model. So everything's moving very dynamic Earth. That's the ITRF. We're going to take out the bulk motion, which is the plate rotating. That's the Eulerpole, which is how we get to the definitions of NatRef, CatRef, PatRef. And you take those Euler poles out, you should get to the same thing, you should get the same plate model as the ITRF at 2020.0. However, as was mentioned, we have a lot of deformation going out west of the Rockies, particularly in California where it rubs against the Pacific plate. So with respect to North America, California is deforming significantly because it's seeing that pulling motion in the Pacific plate. So inside the North America terrestrial reference frame, the intra-frame deformation model for the US looks pretty plain anywhere east of the Rockies, but once you get west of the Rockies, there's a lot of distortion, a lot of vectors that are in there. So in particular, one of the case studies that we actually mentioned is a high-speed rail project from North to South California. Well, okay, if you start that and 10 years later you finish it, and in the interval the thing's moved a couple of decimeters, and you're trying to get this thing banked the right way, you might have some problems unless you can account for that. So the IFDM is how we are accounting for the actual change in the geometric coordinates. It'll help with planning, but it'll also help with trying to understand if, say, you've got a historical survey that's 10 years old, and even if you've transformed it into ITRF 2020, say you kept the original coordinates from 10 years ago, and we thank you, by the way, for doing that if you did. But then we can put them through, we can process them, and we can tell you where you were 10 years ago. But you want to know where you just made a new survey and you want to compare the old to the new. How do you move them from the past to the future? You have to say, 10 years ago, we know where that spot was, and through time, we've seen how the Earth has deformed, and we know where it is now. So then you can migrate all the old data to the current epoch, and you can do the comparisons. So that will be somewhere down the road. That's called survey epoch coordinates that we'll eventually get to. But in the meantime, what we're providing are reference epoch coordinates. So you make your observations now. We tell you where you are in the ITRF now because you're surveying now. But we have a reference epoch, currently 2020.0. So we take all of that and we take those IFDM models and we move them back to where it was at 2020.0. And any new data you collect, we move back to 2020.0. Anybody else's data goes to 2020.0. This gets to the interoperability piece. Now you can stack the data, compare, and see, are you getting consistency in all these different surveys that you might be doing? Maybe it's an engineering survey on a dam. You're looking for deformation. Is it swelling, getting ready to rupture or something? I don't know what application you would have, but we want to make sure that all your observations over time account for the fact that the Earth itself is moving, so that what you're looking at is the true deformation or change in the object that you're looking at. So it's specific to your task. Concurrent with that, that's just describing things in the geometric sense, just the change in X, Y, Z in terms from the ellipsoid. The real world is changing. So like in the case of around the Great Lakes, there's a significant mass change occurring. Mass is leaving the East Coast and going under Hudson Bay. And what it does is that tilts the Great Lakes and produces this huge signal in the geoid. So when you're actually trying to calculate your datums on the lakes and things like that, every 30 years, we find ourselves producing a new Great Lakes datum. And it's because the lake surfaces are tilting as the land underneath them uplift. So that is DGeoid. That is the dynamic geoid. And that is a component that isn't as addressed because it's a lot slower process for the most part. But when you talk about shifting masses like that, particularly in the case of, like I said, the GIA signal, that's probably the most prominent one in North America. But you can get other things going on as well. You can get listric faulting and all sorts of subsidence that occur along the Gulf Coast, Mississippi River Delta. As you start to displace the masses down, you've shifted the masses, and therefore you would change the geoid. So it's not just that the ground went down 10 centimeters. That mass change also reduced the geoid by another centimeter or so. So the orthometric heights might only look like they went down 9 centimeters because the geoid went down a centimeter, and that's the total 10 centimeters that you see in the geometric side. So they kind of work together, but that is what the dynamic geoid is, and that is where IFDM come in. One monitors the change in the geometric, the other monitors the change in the geopotential. And yes, the two do go together. The one the most bang for the buck is going to be in the IFDM. And that's the one we're going to monitor the most because it's about an order of magnitude more significant, the changes that occur there, and they're a lot more rapid. And some of them aren't mass changes. You get a fault, You know, there might be some mass change, but most of it could be maybe strike slip. There's no mass change, but there was definitely significant movement in the Earth's surface, and you can see the deformation signal present from that. I will take the moment then to mention too that the current version, we talked about what we're doing for IFDM. It's essentially change 4D, which is geophysical models trying to describe the change over time. We're going to be looking at INSAR and on a global basis. They've got Sentinel-1 up now, and NISAR's hopefully launching soon, if it hasn't already. Those two missions are going to look at the change in the surface of the Earth. And we're going to map that into, we're working with NASA and USGS to map a national deformation model. For us, we're interested in our stations that are on the surface of the Earth and how they're moving. That's our control. If it's moving, we need to know about it. But it should match because we have active control. We've got those GNSS receivers on the time. We should see motion in those, and this deformation from the outside from INSAR should match it. The good news is then, of course, then that validates what we're doing, but that also provides us a model so we can say in between the IFDM model could be improved to say, now we've monitored all this surface deformation that's occurring, we can tell you a little more precisely and accurately how your position moved somewhere in between the core stations, because you set up in between the cores, not at the cores. So those two are the most critical components there.
You want to mention the... Thanks, Dan.
You're welcome.
Would you like to also mention the future reference epoch coordinates, future reference epochs?
Well, you could do that.
So as Dan and Charlie both mentioned, the current reference epoch coordinate epoch will be 2020.00. We're still looking at when we will update those, either every 5 or 10 years, and we're trying to work that out with the Canadians and the Mexicans. So those reference epoch coordinates will change over time too. So we'll have 2020.0 coordinates, maybe 2025 or 2030.00 reference epoch coordinates, so that that'll help to account for changes over time as well.
The transformations, that's what you're going to get. Right now it's going to be, we're going to be doing it, and that's what the reference epoch coordinates, that's what we're providing in the initial rollout of tools. Eventually there will be survey epoch coordinate capability. That's when you can pick the survey and say, I want it at this time, and you can move it through times to when you want to do that adjustment. And that is what you're getting at, is the survey app. And we won't have that at the initial rollout. That is one of the tools that we're trying to get to later on. Now, to follow up with what Galen was saying too, the reason we're doing every 5 or 10 years, we're still dickering, as he said, is because of real time. You're driving down the road and real-time signals are coming through and you're positioning yourself with those signals. If the ground has moved in the 5 or 10 years, then your road and your navigation might not be coincidental. So the goal is every 5 or 10 years, depending on what we end up with, to jump forward, to take everything, move it forward with the IFDM to 2030.0, and to try and keep the real time more in sync with the real world, with our reference epoch. So I guess it's the other way, to keep our reference epoch more in tune with the real world. Because there are going to be real-time applications, people are going to be navigating, receiving real-world signals at this moment, and we need to make sure that our reference epoch is closely aligned as needed. Again, on the East Coast, we almost have no IFDM model, so what we give you at 2020.0, you look at it at 2030.0, it's going to be pretty straightforward. It's just the oil pole rotation. But out west, it's more profound. And the Canadians want 10 years because they're like, we're not moving. We don't need every 5 years. But we're like, yes, but we have California and the whole West Coast. And yes, they are deforming. So that's where the discussion kind of comes in. I have a hypothetical. How about at a tide station, if you have numerous benchmarks around the water level station and you only GPS 3 of them, how would you try and incorporate that using what we're going to roll out with versus, say, like Opus 6 when we come down around? I'll let that one be for Charlie.
All right, going from applying vertical control with the new NSRS, the modernized NSRS, will be done through GNSS. So you'll basically take your GNSS receiver, come up with an orthometric height on one or more of your points that you're interested in. there's going to be some uncertainty involved with that. But what we'll be able to do is take that and couple it with leveling, and then you'll be able to level between any of the marks or marks in the ground that you're interested in and the water level station. So in that way, we'll be able to use the GNSS to tie directly to the NSRS. And the Opus 6 will be able to take all that data, GNSS and leveling data, apply the appropriate weights to it, and come up with NSRS elevations for not just the water level station, but any of the other marks that you might have leveled to, and also included in your GNSS project.
I might also add on all of that what you observe at that one water level station will then tie into all the other water level stations that you might go through and make survey campaign on as well and do any local leveling. So in particular, if you're looking at tide stations up and down the East Coast and say you want to integrate them all and put them in the same frame, this is the way to do it. If you're looking along the Mississippi River, where they've picked different datum points, which may or may not be reliable, but are still the datum points for each segment of the Mississippi River, you can hit all of those and the water level stations and integrate them all so that you can get the Mississippi River from the lower Mississippi to the upper waters all in the same datum. And you can do that for any of the river datums. So with a lot of the other models you were describing, TerraSAR-X and a lot of the others, they are elevation models. And elevation models are very important to us because the biggest mass difference that you can come up with is the one between rock and air. So that's your elevation model. So when we build a geoid model, the elevation models go into it as one of the parts of our calculation. Two, usually our gravity measurements are on the surface of the Earth. So again, you want to know where were you when you made that observation. So entering argument, even for our gravity stuff, requires geopotential or geodetic information. Where was that gravity observation located? From all of that, then you can integrate and you can get back to the geoid as a third boundary problem. You basically have the value of the signal crossing the boundary, and that's what you're trying to solve as the geoid. That is the solution that we're trying to generate. And we optimize that to fit through, we looked at, when we basically picked our geopotential data, we looked at 200 tide stations. Now, all across the East Coast, West Coast, Gulf Coast, and up into Canada, the tide stations have topography of the sea surface. Pressure, temperature, salinity variations make the water levels vary by a meter plus minus up and down the East Coast in particular. So if you model that and you remove it, we looked at the geopotential values that were left and we got a value that was pretty close to the one used by the International Astronomical Union. And that value is the one we had ended up adopting both in the United States and Canada as the basis for our vertical datum. And the idea behind it is that that surface extends through to the shoreline where we can do the comparisons to the tide stations and make sure we get consistency there. But it also extends that same surface all the way into the interior of the country, and we can look at the potential surfaces above that and look at how the water flows and make sure that it still matches. So we're using actually a lot of the water surfaces to do this. But again, those water surfaces, the top of the water, the bottom of the water, are all scattered on an elevation model. So that's why we work with USGS pretty intrinsically. We're trying to get all their riverine data, we're trying to get all their elevation models all into the same datum so that when we go through and we fly these high resolution imagery models, again, you have to ask yourself, where was that sensor located and how do I integrate that into the same reference system? And that's what we're trying to do. When we do anything with gravity, we already are taking out tidal surfaces. We take mean tide level. We actually take out a lot of the components of the variations as a part of the processing of our software. When we compare it to tide stations, they already do that. That's part of what the National Tidal Data Mechapic is about. They go through and do a lot of that averaging to come up with an epic or a tide level that's the average. They have a mean tide level, a mean sea level, a mean low water. They do all the tidal datums around that based on that 18.6 year cycle. And yes, they account for all the variations. The idea is that over that most recent 18.6 year cycle, this is the level that they've determined is the best fit. And
at that area.
At that area. And again, that's local mean sea level because pressure, temperature, salinity variations, the Gulf Stream is not the same as the Labrador Current. Plenty of variations in that water surface, that's the water topography. And that's one of the things when we built one of the models I think we talked about was VDatum. VDatum in particular in the coastal and the water areas is how we transform between all the water surfaces. Now it'll be to our geoid, which is the best fit to what we think is mean sea level. And from that to all the heights on land. And with the geoid model and the other information, we're able to get back to the geometric coordinates. So VDatum is a means of going from any type of coordinate system, from geometric to geopotential to sea level ocean datums, and move back and forth between them. Oftentimes, a lot of our sister agency, Office of Coast Survey, when they're out there doing their charting, they're in the geometric frame. They're getting geometric coordinates, and they use the VDatum tools to transform their waters to mean sea level or mean low level waters, the typical datum for the coastal areas. But all of that integrates from what we're trying to do, and we do integrate and pull in a lot of that information. The one thing I'll respond with, just to kind of give Galen a little chance, our job is to help you position your sensor. It's your data, your observation. There is so much geospatial data being collected. Our job is to try and help you figure out how to position yourself and find the best way to do that. But in the end, this is what I was talking about earlier in my slides, which was, you know your mission, you know your requirements, and you know what's best to try and achieve it. And we're here to help you try and find the right tools to do that, to do what you're doing. But we're not necessarily going to be capable. The ISO's got like a geospatial data management. There's like 3 primary models. One is transformations, which is what we do at TC211. There's an ISO geodetic registry, and we maintain all the transformations. And there's uncertainties associated with that process. The other is like NGA does, which is they put it all in one big database. Well, they've got the pockets to do that. We don't. And the third is that we give the same set of tools, the same techniques and procedures, and we hand them out and make sure that everybody has them equitably, and then people use those tools to collect their own data and maintain it in their own database, and still then all the data can stack and be interoperable. So our intent is to make sure that all of the customers know they know what's coming. That's probably the most fundamental one, but that they also have the same tools and the ability then to figure out what's the best approach for trying to move forward. Go ahead.
I might add also that as you mentioned, different parts of the country have various needs. That's one way where the Regional Advisor Program can step in and help. If you know of anybody or if anybody has a particular need in a particular area of the country, just contact our regional advisor for that region, and we'll be happy to help.
And yeah, the last thing I'll say is that we do have some estimates, images that I showed a couple of them at the beginning, but they're on our new datums page that gives you an estimate of how much things are going to change, right? So for NAVD88 to NAPGD 2022, there's a tilt to NAVD88 and a bias through the whole thing. So down in the tip of Florida, they're more or less going to be, there's not going to be a whole lot of change, whereas you go all the way up to the Pacific Northwest and you're going to get close to that 2 meter change. And then you go up into Alaska and it's going to be a lot bigger. So we do have some of those maps so people can look regionally, kind of generally what those shifts are going to look like.
To be fair, the reason we're doing it again is practically if you were in the Pacific Northwest and you're stating what we tell you where zero is, you'd be in the water up to here. So clearly that's not zero. And so this is part of the motivation. It's not mapping out to reality. It's consistent but not accurate. That's precision versus accuracy. We're interested in precision, but we're also interested in accuracy, the absolute sense.
So NGS, so I was hired 20 years ago, and when I was hired, I was the second person in 7 years that was hired. A lot of the tools that were built by people that have been there for a while and that were cross-trained, right? They were computer programmers and geodesists, and those are the folks that built those tools. And we have a huge code base of tools that people built to meet their own needs, and that a lot of those got released because other people wanted to do similar things. But historically, there wasn't this organization to what specific tools we're going to build and we're going to release, and so we have this whole library of Fortran code now. As you can imagine, the number of people that know Fortran, can write Fortran and such now, yeah, there's at least one here, that's dwindling, right? And it's not, there's a whole bunch of reasons, right?
Two.
A couple. So there's a whole.
No.
Right. So we use Fortran just as an example of the fact that we have a long history of code development and tools, and we are now working to make a standardized set of integrated tools in common modern languages that are more accessible. And so we're putting them up on GitHub. When we're doing that, we're trying to take advantage of more modern technology and sharing. So that's what we mean, is that we've got this whole big library of tools that we are trying to modernize and have a set of tools that work in modern languages and more importantly, work together, work consistently together.
Keep in mind, historically, being as somebody who wrote his first program on punch cards, we developed our software. There was a lot less rigor. We didn't really have IT security back then. We barely had the internet, so I had a server sitting on my desktop. There were so many things that are different now than they were then. Part of it was I got to write my own code to try and do, and Fortran was very linear. It followed your thought process. You just code it, and you saw a problem, and you could solve it mathematically, and it was great. But it is not a production software. If you want to put it on a website, if you want to serve it in an efficient manner so that when people submit thousands of petabytes of information or whatever they're going to be doing to us to try and get their data processed and uploaded and received back, that's a lot of data. And it is not an efficient program for that purpose. So what we do, and what we always have done, is whenever we migrate, and this is true whether we still have the same Fortran and we're moving to a different server or we're going from one set of code to another, is we write the code in both. And we run it in both. And we look at the results in both. And if we've done it correctly, we follow IEEE specifications, and you see the differences, they should be out there, either depending on what you picked, Real Star 8 or Real Star 16. I don't think we do any of that, but Real Star 8 typically is about as much as we want to do. If we do that, then you typically don't see any of the differences until you get up beyond the millimeter range, way beyond the millimeter range. And when we see that, then we have confidence that the new code is representative of the old code. You don't move on. You have to prove the new process before you can adopt the new one. You have to compare it to the old one, make sure that you get the consistent results, and you have to do studies in different areas to make sure that you trust that code and that it's more efficient. And that's the thing. I mean, we can do parallelization. There's a lot of things you can do, but Fortran is pretty good for that. But in the end, there are much more efficient production softwares that are out there, and that's what we do. We can have all the code we want. We've developed these ideas on what we're doing. But once we've created the model and we've done all this stuff, now you need to render it in a format that is more rapidly available to people. That's not Fortran. It's great, but not for that.
Just to emphasize what Dan was saying, I was on an email thread this morning where Drew, our NSRS modernization manager, was talking to one of the people writing new software, and he wrote his code in Fortran, and that's what he does. And of course, she wrote her code in a modern language, and they compared outputs, and they're synchronizing right now. They're figuring out where any differences might be. So it is a real thing.
So you're receiving signals from a satellite in space at a receiver in the air, on the ground, on the water, wherever you might be. Those signals that you received are proportionate to your location. So if you keep your original observation files that you received down from the Rhinix or whatever you've got, that you received from the satellite, you can reprocess that at any time. That's that resubmit, or resurvey, or not resurvey, but readjust, that was it, readjust option. You've got the data in the can, don't throw it away. It has all the information in it from that satellite. And we might change, ITRF 2030 might come along, I don't know. But what we will do is we will then go back to those satellites that are in orbit, and we will calculate where they were when you made that observation. So those signals you receive from that satellite will be in the new reference system, and we'll be able to figure out your new coordinates in the new reference system. So keep that, keep your, any other, if you derive data from that, if you start to derive it down to, that's part of what we're talking about when we get into like versioning. When we start, you say you're going to come out with a latitude, a longitude, and a height. Okay, then you needed to know when it was collected. You want to know what version of AFDM you use, what version of oiler pole you use, what fill in the blank. There's a lot of information and a lot of intervening models that come between what you observed in that Rhinex file and what you finally get down to in terms of the final set of coordinates. Any one of those models or assumptions that touch on that, you need to keep in your versioning. That's a part of your metadata that's associated with those coordinates. So when we give you a set of coordinates and say later on, we say, we're going to change out IFDM 1.0 to 1.1. We found some problems in this area, the velocities aren't matching, we've improved them in this area. Great, but you know that you had 1.0 and you were in that area, so you can go back and you can remove that 1.0 and you can apply 1.1. And you can update your coordinates without having to go through a lot of that heartache. That would be a readjustment, a smaller one. But again, that's the versioning that we talk about, and that's, I think, it's one of the things we talk through, and I'm not sure if it's in the blueprint, but it's certainly an aspect of one of the things we're trying to do is when we output results, part of it is understanding what information went into giving you those coordinates.
Right on. Okay. Thank you. Good wrap-up question. So ngs.noaa.gov is our main website. You can access all of our tools on there. From that page, there is links to our new datums pages that provide a lot of information here, links to the blueprints and all of that kind of stuff. On the front page, which we're going to be updating here soon, there will also be links to all of our beta products. So you can keep an eye on the beta products there, as well as the alpha site. There is a spot on that homepage to sign up for NGS news. So we send out newsletters on occasion, pretty regularly. There's a couple of other, there's a training email list and a webinar email list that you can sign up for to make sure that you are notified when we've got new trainings or the webinars that are coming up. And then for feedback for our tools, ngs.feedback@noaa.gov. That email will come to me and I'll make sure it gets to the right folks. The other thing is, get to know your regional geodetic advisor. These folks are invaluable all over the country. Great sources of information and collaboration. Regional advisors are great. Our testing and training center down in Corbin, Woodford, Virginia, has a lot of free courses on there, as well as helps to coordinate training and such. And then keep an eye on the website for the webinars. Monthly webinars are coming out, trying to keep pace with what's happening as we do modernization. There's an NSRS modernization newsletter that comes out quarterly, I think. So there's a lot of information out there if you ask and if you look. Either of you want to say anything else?
Sounds good to me.
That's all, folks.
All right. Well, with that, thank you all very much. Really appreciate your time and attention today. And let's look forward to the modernized National Spatial Reference System in the years to come. Okay.